All right, the taping has started. Good morning. Today is Tuesday, the 7th of March, day 37, I believe it is, of our class. And we'll be going over chapter 2 in about a minute. All right, the rest of the period, just as yesterday, will be lab. Tomorrow, same thing, but with chapter 3. I don't know if I mentioned it or not yesterday, but even if I did, I'm going to repeat it. On Thursday, I'm actually going into the campus because usually about half a dozen times per semester, we have what's called Shadow Attack, where students can come in from the outside and observe a class in session. Now, not to be funny, but why somebody'd want to watch me talk to the computer is, beyond my comprehension. But if they want to, they're welcome to. And as of right now, I've got 2 students who are signed up to do so. Now, this will be the third time this semester that I've had a shadow attack. The first 2 times, nobody showed. So it's possible nobody will show on Thursday, or I might have 1, or I might have 2. I don't know. Okay, Friday will be our typical lab period, as it says, with no taping done. Your bootstrap test is due tomorrow. All right, tomorrow night by midnight, and your chapters 1 through 3 stuff literally won't be due until a week from Sunday. That said, now yesterday we went over chapter 1 from our text. All right, so we went over Introduction to Web Development. So chapters 2, 3, and 4 are really meant to bring you up to speed and talk about most of the specifics of the JavaScript language. So I'm going to jump right into chapter 2. And notice it says the goal of this chapter is to get you off to a good start with JavaScript, especially if you're new to programming. Now, about half the class that is in this class right now, last semester, was in the AWD1000 C# programming class. So you've already got a little bit of a leg up on those people who have no programmatic experience. That said, my hope is that on Thursday, when we go through a couple of examples or a few examples as a class, that even those of you who have little to no experience are going to say, well, this isn't that bad. All right. And as you'd probably guess, as time goes on, it'll get harder as well. All right. So we've already talked a little bit about this, how to include JavaScript. I went over some of that yesterday. But we've got about 6 pages on JavaScript syntax, and it's not everything. Then we'll talk about the JavaScript data types, expressions, all right, objects, methods, and properties, and we'll look at these 2 illustrative applications. And in fact, I will bring each one of them, the miles per gallon and the test applications, up in Visual Studio, and we'll take a look at them in there. All right, okay. So we've already mentioned this, but I'll say it again, that there are really 3 ways that you can bring JavaScript into a program. You can put it in the body section, and historically, that's been the way that people have done it. And the reason for that is they put it in the body section because the body loads after the head has already loaded. So if the body is going to take advantage of something that was defined in the head section, all right, the head section should already be loaded. All right. And for years, that's what people did. And you'd see it in books. Hey, if you're going to put it in there, make sure that script statement is the very last statement before your ending body tag. All right. And just so you know, too, it's totally legit. Just like we could have more than one CSS file, we can have more than one JavaScript file as well if we want to or need to do that. So that's first way. Then the next way was to put the code in there actually almost inline between script tags right in the body. And you could do the same thing if you wanted to right inside of the head. All right. Again, this is kind of discouraged because what you're doing again is you're putting JavaScript right inside of your HTML file, which is considered very poor practice. All right. And the other way they don't mention right here, but I've already mentioned it, is you can take that script tag like this and you can put it in the head section. If you do, after the word script, put the word defer, then your source equals. All right. And the defer means defer actually bringing this file into the system until everything in the head has loaded. All right, and that's pretty much the way it's recommended that you do it today. So I'm not going to sit there and read this stuff to you. Again, just like with CSS, there are a multiple number of ways to bring JavaScript into the program. Some are more preferable than others. We'll just leave it like that. All right, this no script element, it is legal, legitimate, whatever you want to call it, that if, and I haven't done it in quite a while, but if I go up here, this is to customize and control my settings in Chrome. If I go into settings someplace in here, if I want to do that, and I don't, but you can turn off JavaScript. There are people, there used to be articles that JavaScript was evil, that JavaScript cookies were going to steal information from you. Most of that, and in fact, virtually all of it is a lot of BS. It's not true at all. All right. But just in case someone has JavaScript turned off on their computer, you can add no script tags, as they mentioned right there. All right. And I'll just leave it at that. It shouldn't be an issue for us. To my knowledge, everybody will have JavaScript enabled. So here's how you can disable it in Chrome. All right. So I just showed you that you can go up here, click, go to settings, and they mentioned it under settings. There's a privacy and security, and somewhere under there, you can go in and you can turn off if you want to. You can turn off JavaScript. I don't see the real advantage to doing that ever. But, again, everybody's got their own reasons for whatever they do. All right. And if you do disable it, they show you how you can enable it, etc. All right. So let's start talking about syntax. Okay. I mentioned to you yesterday that in a way, JavaScript is both one of the best languages to learn when you're first starting and one of the worst. And as I said, it's for the same reason. It's one of the best in that if you forget to do something, typically JavaScript behind the scenes will do it for you. And that's the good part of it. The bad part of it is most other programming languages are not set up like that. All right. And if you make mistakes in most other programming languages, the program just won't run. But things like, and we talked about these a little bit, we looked at them yesterday. All right. If you don't put semicolons in, you saw in the programs that I created yesterday, or the miles per gallon program we went over, I've got it set up inside of Visual Studio Code that even if I add semicolons to my JavaScript, they're removed anyway, and everything still worked. Some people like to put semicolons at the end of every line. All right. And there's going to be other things as we go in here. Sometimes I'll even deviate from the book, or I might mention something that's not in the book, etc. And it's just stuff that I've learned over the years. All right. And what I'm saying too is I was reading an article this morning that was it was called Languages You Should Not Learn in 2023. All right. And it was interesting because the first one they listed was C#. And I'm like, whoa, that's interesting. Let me read why. And this person's view was that setting it up, the amount of disk space it takes, the amount of time it takes to learn the language and learn it well isn't worth it. All right. Again, at the end of the article, in the conclusion, the author said, this is just my opinion. It basically doesn't mean squat. All right. And in here, what we're looking at right now, that yeah, we are going to go look at the rules for summarizing JavaScript statements. But again, if I give you my take on something, that doesn't mean you have to do it that way. What should be happening right now, especially when you're in the first year of the program, all right, is you should be kind of discovering the way that it makes sense for you. All right. Now, if you have this summer, if you have Mr. G for a class, Mr. Gudmested, and he has a different way of looking at things than me, that's a good thing, not a bad thing. You're just being exposed to somebody else in a different way of doing things. And when I say a different way of doing things, I just mean basically a different syntax or whatever. All right. So speaking of syntax, as it says, there are the rules you have to follow when you're coding statements, whether it's JavaScript, or it's C sharp, or it's something else. Every language has its own syntax. All right, even English has its own syntax. If you look at this line of code right here, you can see when there's a little break in the thought, there's a comma. All right, when we're combining two words together like don't and won't, basically, all right, we have the apostrophe and we have a period at the end. Well, JavaScript has its own syntax. The first one is the biggest thing that's in there. JavaScript is a case-sensitive language. All right, so yesterday, if you remember, we created three variables. One was called miles driven, and MILES was all in lowercase. The D in driven was in uppercase, and gallons used, the word gallons was in lowercase, and the U in used was in uppercase. That's typically referred to as camel case, like you see right here, where the first word is all lowercase, but any word that you append onto this, all right, the first letter is an uppercase. That's usually the way that most people create their variables in most languages, including JavaScript. All right, are there exceptions? Of course there are. But again, the first rule, as it says, is JavaScript is case sensitive. So with JavaScript, this and this are two different variables. All right. And we're going to see something a little bit later on this page that talks about strict mode. JavaScript, as I mentioned yesterday, can be one of the worst languages to learn because unless you use strict mode, if I use sales tax like this throughout my whole program, then later on in the program, I use this, I don't get an error. JavaScript literally on the fly creates that new variable. It won't have anything in it, but it creates it and it doesn't let me know that. The second rule, again, I'm going to deviate from that. It says JavaScript statements should end with a semicolon. All right. As it says, to remind you, some IDEs will issue a warning if you omit them. We're not using really an IDE, an integrated development environment. That's what we used Studio Vision, which is more a high-class editor than it is an integrated development environment. The third rule is JavaScript ignores white space in statements. White space, as it says there, meaning spaces, tabs, new line characters, etc. So most of the time, you can put things on multiple lines, but there's going to be times that you won't want to do that, or if you do it, it may not give you the results you think it will. All right. Finally, as it says here, JavaScript has a strict mode. And all you have to do to enable strict mode is put this at the top of your program, this use strict directive. When you do that, it tells JavaScript that if we did something like I mentioned before, where you've got sales tax throughout your program, and now you have this, you will get an error that says, hey, you've got a variable in here, and this variable was not declared. All right. So it's a good thing to put it in there. All right. It says you should always use strict mode unless you've got a good reason not to. I agree with that. That said, do people break that rule? All the time. All right. Just because you should do something doesn't mean that you do it. All right. So they're starting to show you a few things in here. There's the use strict. Typically, I wouldn't do it the way they're doing it here. I put it at the very top. It's my first line in JavaScript if I'm going to use it, right at the top. All right. This is a block of JavaScript code. The reason I bring this up is sometimes depending on how your editor is or is not set up, or depending on how you want to run things, I like to have the curly brace. Typically, I put it, this left curly brace right there, I typically put it on a line by itself. And then I put the next else if on a line by itself. Not everybody agrees with that. All right. Again, you should come up with a way of coding and you should stick to it. I've oftentimes said this, that if you come up with your own protocol for doing something and you are, pretty much very consistent with the way you do it, even a bad protocol is better than none at all. All right. So again, these basic rules we already talked about. JavaScript is case sensitive. Many people want to end it with a semicolon. That's up to you. But I think that that should be an all or nothing type of proposition. So if you decide, hey, I want semicolons, then put them at the end of every JavaScript statement. All right. All right. Now, this splitting the statement after 2 lines, let's take a look at that when we get into this more and we're looking at more code. All right. I've oft-time mentioned in the last book, and I'll say it again in here. If you're not a big reader and you don't know stuff, at a minimum, you should be looking at the odd number page. And when they have things, be it code or be it tables or be it bullet lists, you should read through those. And usually if they have a description or something at the bottom, it's going to be a summary of what was on the previous couple pages. All right. The next thing are identifiers. All right. And I'm looking at identifiers as a name given to something you create. All right. That's given to something you create. It could be the name of a variable. It could be the name of a function, which we haven't even talked about yet. It could be the name of a class, which we haven't talked about yet. It could be the name of an object, which we haven't talked about yet, etc. All right. It says there you can't use the JavaScript reserved words, also known as the JavaScript keywords. Probably that's either on the next page or it's coming up. If for some reason, I know they had it in the last version of this book. If we don't see it, we'll go in and Google it. It's not hard. There's somewhere around 60 reserved words. All right. Let's see. It says you should give your identifiers meaningful names. There are going to be a few times when you can deviate from that and give it a really bad name. All right. If you say, I don't understand, you will when we get through it. Okay. When we get to that point. All right. And they give an example like we did yesterday. MPG is a common abbreviation for miles per gallon. All right. But, if I'd have done MD yesterday for miles driven and GU for gallons used, you and I might have known what it was, but other people looking at it may or may not have. So sometimes it makes more sense to actually spell out, even though your program is a little bit more verbose, it's a little longer. All right. It's also more self-documenting. All right. So camel casing, we already mentioned, there's a couple of examples. All right. You can use snake casing. And if you'd rather do it that way, you can do it that way. So rather than monthly investment like this, you do it like this, and everything is lowercase, and between each word, you put an underscore. If you would prefer that, then you should use that. But again, I would recommend that you are consistent. You'll notice it says in this book, snake casing is used for ID names and for class names in HTML. Camel casing is used for basically anything you create in JavaScript. And as it says there, it does it so you can tell if something does have an underscore that it's related to the HTML, and if something does not, if it's camel cased, it's JavaScript. All right. But again, all I ask is that you try to be consistent more than anything else. That's going to do nothing but help you. I always remember this a few years ago when I was teaching at another school. I got an email from a guy who was looking for somebody. He ran basically a hardware business, and it was a chain, and he was looking for a programmer. And he asked me if I had anybody I'd recommend. And there was one guy in what he was looking for who was very strong in it. And he said, I'll tell you what, can you come in next week, pick a day, and can you bring the student in with you? All right, I already knew him. I'd been to meetings and stuff with him. So I asked the student, we went in together. And the student asked me the day before, he said, should I bring in examples of some of my code? And I knew he was an excellent coder. He followed good conventions. He put in documentation. I said, yeah, that'd probably be a good idea. I was not only surprised, I was amazed that this guy probably spent half the interview looking at this kid's code. All right. And they ended up hiring him. It's a success story, not to me, but to him. And I know that when I talked to him years later, he was still there, and he had moved up and he was a senior programmer there. All right. So these identifiers, here's the rules. Okay. They must start with either a letter or an underscore. They can only contain letters, numbers, underscores, and the $sign. All right. They're case sensitive. They can be as long as you want them to be. They can't be a reserved word, and they shouldn't be these global properties, which we'll talk about later. So let's break this down and say that if all of your identifiers contain only letters, then you don't have to worry about any of these other rules, except you can't make them like the word if is a keyword. So you couldn't make your own variable called if. All right. I would not recommend using underscores because sometimes what you'll find especially if you start a identifier with an underscore, that's what a lot of system variables start with, is an underscore. And the $sign is used in variables in the PHP programming language. That could prove confusing to people. So I'd recommend using letters whenever possible, doing it in camel case, and only putting in numbers if it's necessary, but it can't be the first letter, or it can't start with a number. All right. So they give you some things here, some valid things, some invalid, and there'll be some invalid as we go through here, etc. Some of these I've already mentioned to you. Use meaningful names, be consistent. You heard that already from me. If you use snake casing, use lowercase for everything. And here are the JavaScript keywords, or reserved words as they call them. And it looks like there's 63 of them if I just counted this correctly. All right. So and there are some of these, just so you know, some of these have been denoted as keywords, but they really don't have a meaning yet. What that means is they were set up as keywords real early in the process, knowing that somewhere along the line, ECMA, the European Computer Manufacturer Association, may want to use those words and have a special meaning for them. All right. Okay. Comments, two ways to make comments. Let's just look right here. There is a multi-line comment. It starts with a /*. It ends with a */, the same way that we wrote comments in a CSS file. The other way that you can make a single line comment is with 2 forward slashes. Wherever you make 2 forward slashes, the rest of that line over is a comment. It's a very fast way to comment out a line of code. On the other hand, if you want to comment out an entire group of code, maybe several lines, it's typically better to use the /* and the */. All right. So that's known as a block versus a single line comment. I've given you my different guidelines for comments before. All right. Anytime, the litmus test that I use for this is if I have to ask, does this need a comment? If I have to ask the question, it probably does. All right. But you don't need comments. If you add 1 to a variable, you don't need a comment after it that says we now incremented the variable by 1. That's just a waste. All right. Okay. Notice as it says, comments are ignored when JavaScript is executed. So in other words, they are skipped, or whatever you want to call them, when Java goes through the process of being interpreted. Okay. All right. Okay, let's talk about working with data. And what I'm going to say right now is going to sound a little bit weird because it is not the way that it is in C#. So this is one of those times when we're going to start to deviate between languages. All right. They mentioned there, when you develop JavaScript applications, you not only frequently, you will typically work with data. All right. So JavaScript provides 7 different types of data. Now, the first type is number. If you remember yesterday, we looked at parse float and we looked at, or I mentioned parse int. Parse float is what you use on a value that can potentially contain a decimal point. All right, parse int is for a whole number, a number that doesn't have a decimal point. That said, JavaScript has only a number data type that represents all numeric data. It doesn't matter if it's a float or an int. It's of type number. So even though there is a parse float and a parse int, they're both of the number data type. Numbers can contain signs. Most of us are used to using a negative sign. But if for some reason you wanted to, you could preface your positive values with a plus sign. I've never seen it in actual application code, but you can do that. All right. Numbers that use decimal places are called floating point numbers. Sometimes in some language, they're called doubles. Sometimes in some languages, they might be of type decimal, etc. All right, but it just means in all those cases, they can, CAN, potentially, they can use or have a decimal place. The string data type. This is where it's different again than C#. Strings can be either double quote followed by a string double quote or single quote followed by some text followed by a single quote. All right. And the empty string is either two double quotes or two single quotes, meaning literally that it's empty. You're going to see a couple of examples on the next page. All right. Then there's Boolean. We talked about this yesterday with the is valid data or is valid. And that's something that can hold only true or false. And that's it. All right. And as they mentioned, these are the ones that you're going to use the most. In fact, probably 90% plus of what you do will be either a number, a string, or a Boolean. All right. But there are other types as well. There is a symbol type. All right. I'm not going to talk about that at all because, as it says, when we get to chapter 12, we will talk about it at that time. Not only that, all right. I have never had reason to use the symbol data type in any programming JavaScript I've ever done. I'm not saying that it doesn't have a place. I'm just saying I've never found that place. Then there's null and undefined. All right. So if I go and create a new variable and I come in and I say, let age equal 21. Well, if I say that, you saw something like that yesterday. So let me just show you this real quick. And I know, Grant, you know what this means, but again, there's going to be people who don't. If I say this, let age equal 21, like that, and it doesn't matter if there's a semicolon or not. This right here, this is a variable declaration. I am declaring a variable right there that is called age. This is a variable initialization. All right. So I'm initializing it. I can do this over two lines. I could say let age, and then I could put underneath that age equal 21. Totally legit to do that. Or, again, I could just put it in there like this. That's typically the way you're going to see it, is like this. All right. And to me, it makes more sense to do it like that as well. All right. Oh, and what I wanted to mention is if we do this, right now the value of age is undefined because we declared a variable, but we did not give it a value. In some programming languages, if you were to do something like this, it would immediately have some kind of a value associated with it. But I'm going to show you something right now, and this is something we have not yet talked about. This is one of, if not, probably this is the biggest difference between JavaScript and C#. So this is it right here. So if I come through here and I say, let age equal 21, all right, like that, then I'm going to put here ... meaning there's some code in here. I don't care what it is. But if later I come in and I say age equals, and I say false, so now it's a Boolean, JavaScript lets you do that. All right. So I can change the data type on the fly like this. So now I'm a little bit later on in my code and I say age equals hello. It lets me do that. Change the type of data that a value holds at any time in JavaScript. This is, like I said, when I said that it can be one of the worst languages to learn, it's because there's very, very few other languages. The only other language that I know of that allows you to do this is PHP. All right. So there are very few other languages, at least that I know, that allow you to do things like this.
So
and you might say, well, fine. Why would you want to do that? It's not so much that you'd want to, it's that you can.
So
all right.
I've got a quick question. How
Sure.
would the program read that if you have, say, like an equation with a numeric value? How would
If
that
you,
process
if
that
I don't know if
in
this is
your
what you're
string?
saying, but if you did this, like that,
Yeah, something
yeah,
like that.
it's gonna, the program will break.
Okay.
Okay. Now, if you have this line here, of course it'll work, but you could come in and do this. Either double quotes here or single quotes. And most of the time, that's going to actually right there. So if, let's say we did this, that is not the number 21. That is the string 21, the string 21. But if I do this, that's going to actually probably come out and say true, because it'll convert age to an integer. What if I don't want this to be true? All right, what if I want to say if it's actually not only 21, but the number 21, not the string 21? Guess what? JavaScript has its own thing for that too. And it's 3 equal signs.
Okay.
So when you use 3 equal signs, it's the identity equality. It says, hey, is this equal to 21? And is the type numeric? All right. So like I said, in fact, what you'll find today is very few people when they have if statements, very few people will do it this way. They'll almost always do it with the 3 equal signs. Okay. Null means unknown. I've given this example before. It's the first day of class. You walk into a classroom, let's just say, I know we're online, but you walk into a classroom, you say hello to the instructor says hello to you, what's your name? You tell them, hey, how do you like the school? Oh, it seems really nice. Oh yeah, really? I'm going to ask you a personal question. You don't have to answer if you don't want to. What's your grade point average? And for whatever reason they ask you that, and you turn around and you go, I just started, I don't have one yet. Then your GPA is null. It's not undefined. It's null. It's just unknown because you don't have one yet. All right. Finally, there's a big int data type, which again, I've never used for very large and very small numbers. All right. So here is a chart with the basic ones. And again, I'll go out on a limb and say that you will use numbers, string, and Boolean, all right, more than 90% of the time. You'll very rarely, if ever, use symbol. You'll very rarely, if ever, use big int. You'll very rarely, if ever, use undefined. Null, you may have a reason to use that. And remember that when you are creating, Java doesn't have a character type like we had in C# when you had a single character. In Java, or I'm saying JavaScript, I should say, not Java. In JavaScript, this double quote JavaScript double quote means the same thing as single quote JavaScript single quote. So you can use double quotes or single quotes. You can't mix them and start one with a double and end it with a single or vice versa. But you can use either double quotes or single quotes. This is called the empty string. There can't be anything in between these, even a blank space. So double quote, or single quote, that's the empty string. Boolean again, true and false. And I think we pretty much have discussed everything else that's on this page. All right. All right. How to declare and initialize variables and constants. This is a little quirky as well. And as I've already mentioned, there's a few things in this language that I'll just call quirky. They are. All right. So when you create a variable, and I've already shown you an example of that, age right there, age is a variable. If, some books will say this, look at a variable as kind of like being a box, and that box can have a value inside of it. So I can say, let age equal 21, let name equal Jeff. All right. Or, even something like this, where I would say, let first name equal Jeff. Let last name equal Scott. Let is married equal true. All right. Let salary, let's just say that I make $55,555.55 a year. All right. So those are examples right there. There is an integer variable, but it's of type number. There is a string. I can do this one if I want to as single quotes. There is a string. There is a Boolean, okay? And there is of type floating point, but again, it's a number, all right? And again, as I already mentioned, if I do this, I can say, I don't know, let department. So let's say that I don't have a department. Now that's going to be undefined. If I want to, I can typically take almost anything and initialize it to null. That's not undefined, that's unknown. So it could have a value, but no one knows right now what it is. All right, going back to the example I gave you before with grade point averages, I don't want to assume that if you're a new student, I don't want to set your grade point average to 0.00. Boy, boom, then you're on academic probation because you failed everything. All right, so for GPA, I would do it more like this. Grade point average. All right. All right. Now, when you do this, and this is where it gets a little bit confusing. All right. You'll notice that in every example that's there, all right, we're using the word let. Let should be used on any variable that you create that could conceivably, if you know it will have its value changed during the life of the program, or there's a chance that the value will be changed throughout the life of the program, you should preface the name of the variable with let. And Grant, for you and for everybody else who had C# last semester, notice you don't put a data type in there. All right, so you don't say int count equal 1, string name equal Joseph, etc. It's just let. That is one of the reasons that you are able to go and change the data type on the fly. Now, if you've got variables whose values will not change, you can make them a const. Const is a keyword that is short for constant. All right. Now, what I used to have people do, even as close as much as a year ago, all right, was whenever we created a constant in this class, we made them uppercase. And I might have even done that yesterday. I don't remember. In fact, we may not have even had a constant. All right. But that's changed a lot over the years. All right. And what you're going to notice, those of you who this summer will take the AWD1111 class, the database-driven web development 1 class, or those of you who take it in fall, that when you use Node.js, which is JavaScript on the server, whenever possible, you able in there a const, and you very, very, very rarely use a let. And you do that because the program runs faster because of the way const are set up internally as opposed to the way lets are set up internally. All right. Okay. So as it says, a variable stores data that can change. It can vary. All right. Now, this is not exactly true what they said. A constant or constant variable stores a value that may not be reassigned once it's created. That's true most of the time. But later on, when we start to talk about things like arrays, and don't worry about what they are right now. I think we're going to be introduced to them tomorrow. But again, don't worry about them right now. But you can change the contents of an array that was defined as being a const. All right. Okay. So to declare a variable, you code the keyword let and then the variable name. That's the declaration. If you want to initialize it at the same time, it is an equal sign followed by a value. Now, I don't know about you, but if I ever read this, I would read this as let age equal 21. Makes sense to me. Literally, what this means is take the number 21 and assign it to the variable age. Well, no one talks like that. All right. We all just say let age, equal, etc. All right. And one more thing regarding that's important to realize that if I put this in here, let address equal, and I put in here 751 Parr Road. This is the Wentzville, the Rankin Wentzville campus address. Now, I would read that as 751 Parr Road. But one thing to realize is anytime you put something within double quotes, this is not truly a number. This is not really 751 Parr Road. It's 751 Parr Road. The reason I bring that up is more for the people who are taking, this is your first foray into programming. Has numerical value of what you see there in green is 0. And that's because it's in double quotes. All right. And, I mean, we can go through every one of these, but we've gone through most of them. When you declare a variable or a constant, do not put commas in it. Do not put dollar signs in it, etc. Don't put any different types of characters. When you code a string, it can be single quotes. It can be double quotes. Mix them. When you declare a let or a const that's going to be numeric, don't ever use double quotes if you want it to be a number. If you assign a value to a Boolean, you can only use true and false, and they both must be in lower case. All right. All right. So this is a little bit confusing here, but let's take a quick look at it. It says here on the next page, it says JavaScript. You'll be giving some basic information about how JavaScript treats variables and constants you declare in code. It says, understanding this can save you trouble later on. When JavaScript code loads, the JavaScript engine scans it and stores any variables and any constants. Doesn't matter where in the program they've been declared. Top, bottom, middle, in what's called a function that we haven't discussed yet, can be anywhere. It looks at all those first. All right. And it grabs the value and it stores them in memory. Then, as it says, it goes back and it executes the code in the order, it does it sequentially. It says this process is known as hoisting. All right. It says because it seems like the variables and constants have been hoisted at the top of the file. All right. It's as though you declared them at the top of the program, regardless of where they were actually created. Well, this is one reason you don't declare var. All right. It says for variables declared with var, JavaScript also initializes them to undefined when they're hoisted. All right. As a result, it says if your code refers to one of them before it's declared, all right, JavaScript will tell you that it doesn't exist, even if it does. All right. And you might say, well, maybe that's a good thing. what happens when you declare things with var, you can declare it anywhere you want and use it anywhere you want. So you can even use it in places where technically you shouldn't be able to use it. It leads to really bad programming habits. The recommendation today is that you never, ever, ever use var variable. And I do the best I can to stick to that. By contrast, it says there, variables declared with let or const are not initialized when they're hoisted. It says because of that, they cannot be used until you do give them a value. And if that confuses you, let's take a look at a couple of the examples. So this is the hoisting process right here. This is what I just read to you. All right. Now, if you try doing this, as it says, if you come in and do an alert on val1, so val1 hasn't been, down here is where we're declaring it. All right. But if I do an alert on it, it'll say undefined. Is that a big thing? It really isn't, but just to show you this, let's go and bring this up. So I'm going to come into here. All right. In fact, I don't need that. Let's see what's the best way to bring this up. I think I can do it from here. We'll do it like this. Let's go back to what we looked at yesterday. I've created my own folder with JS Murach in it, and this was that email program that we looked at yesterday. Okay, I'm not going to do anything with the program, but I am going to right mouse click here, and I'm going to inspect. Okay, now if I come in here, all right, it looks like that we might have an error. Don't worry about that. But if I do this, okay, if I say alert, hello, all right, hello is not defined. It's giving me an error. Technically, the value of it, since it's not defined, the value of it is undefined. But if I come in there and say hello, whoops, hello equals hello, like that, and I hit enter, now if I say that again, if I say alert hello, okay, notice I get that. All right. And the reason that that is important is it shows you the distinction between something that you try to access that has not yet been defined, as opposed to something that you access that has been defined. So notice if I come in here now and I say, let age equal 21, boom. And now I type in age, and it says 21, exactly what you'd expect, right? So now let's come in here and say const, and we'll say, I don't know, name equals Ben. Okay, now I come in here and I say name, and it says Ben, exactly what you'd expect. But now I want to come in and say name equals Sally and hit enter. Well, notice what it says. I get an error that says I'm attempting to assign to a constant variable. In other words, I have said that name is a constant. So name cannot change. I couldn't even change it from Ben to Benjamin, all right, or something like that, because it's a constant. Now, it used to be that in most programs, the only thing that you came in and you made a constant was you'd say something like const, and then you'd say inches in a foot equal 12. And that's how people mostly created constants. All right, because it made your program more self-documenting to say inches in a foot than it did to say 12. Now today, you'll very rarely see constants in uppercase. I still do them once in a while, all right, but you don't see them that often. All right. Here we go. So the rules about hoisting, okay, so variables declared with var are initialized when they're hoisted. Variables with let and const are not. A variable declared with var is always accessible. It doesn't matter where you are in the program. You can use it anywhere. All right. All right. A variable declared with let and const is accessible only between the time. Basically, it's wherever you've defined it. And if that doesn't make sense, it will when we get a little further into the class. All right. As it says, in general, you should avoid using var with new code. You'll still see it in legacy code, in online examples, because some people are just lazy. All right. All right. An expression uses operators to perform operations on values. So here's your major things. So let's start with the four that we all know and love. Plus for addition, minus for subtraction rather, and asterisk for multiplication, and a forward slash. Don't use a backward slash. A forward slash for division. All right, so again, looking at those examples that we just went over a second ago, if I come in here, if I want to clear my console out, I think it's console.clear. There we go. So if I come in here and say, let A equal 12, let B equals 5. Now I can say, A plus B, and I get 17. 12 plus 5. A minus B, 12 minus 5 should give me 7. A times B, so 12 times 5 is 60. A divided by B, 12 divided by 5 is 2.4. I don't need the blank space in between these. I just did it so you can read it well. All right, now let's look at the next one. A percent sign B, and I believe that'll come up to 2. That's the remainder operator. It's also called modulo or modulus. So if I take 12 and divide it by 5, if you remember back in the days of grade school or junior high, we would have said that is equal to 2 remainder 2. All right. Well, the remainder part is what you get when you do this. So if I do this, 60 mod, it's the way it's oftentimes read, 4 gives me 0, because 4 goes into 60 15 times evenly. But if I say 60 mod 7, it comes back with 4, because 7 times 8 is 56, and the remainder is 4. Normally, when you're going to use the modulus operator, normally it's going to be for dollars and cents, or you're working with time, you're working with something like that where you've got a bigger value that you're collapsing down into smaller values. All right. That's a little bit of a generalization, but by and large, it's going to hold true. All right. All right, let's quickly go over these other ones that are here, and then we're going to take a break. Now, the next two are what are known as the auto increment and auto decrement operators. Auto increment and auto decrement. So going back to the example we just looked at here, I'm going to say let z equals 27. All right, so the value of z is 27, exactly what you'd expect. If I want to add 1 to z, there are actually 4 different ways that I can do it. I can say z equals z plus 1. That'll work just fine. So now z is 28, as you can see. I can say there's a shortcut that z plus equals 1. And now you'll notice it's 29. I can say plus z, and now it's 30, or I can say z plus plus, and now it's 30. Oh, z plus, okay, now if I say z, it's 31. We'll talk about why that's the case in just a second. But you'll never see a professional programmer who'll do it like this. If you want to add or subtract just 1 from a variable, you use the plus plus or you use the minus minus. In just a second, I'm going to show you the difference between them. All right. But those are the different ways that you can do this. So let's talk about what the difference is between putting the plus plus at the beginning and putting it at the end. So let me clear this. All right. And I'm going to say let G equal 12. Okay. Whoops. So G is 12. I don't want to change G. All right. But I want to come in here and say, let H equal G plus plus. What that says is take the value of G, which is 12, and assign it to H, then add 1 to G. If you say I don't get it, just watch if you would, please. Okay? Now it says undefined. H should have a value of 12, and G should have a value of 13. So if I type in H, it's 12. If I type in G, it's 13. Because when you use the plus plus after the variable name, it means assign and then increment. Assign and then increment. All right. Had we done it the other way, so had we said, let H equal plus plus G, that is increment and then assign. So it would increment because the plus plus comes before the variable name. So it would add 1 to G, meaning it's 14, and then assign that 14 to H. So if I hit enter, now if I type in G, it's 14, and if I type in H, it's 14. And hopefully it makes sense to you that the minus minus works the same way. So let M equal 9. All right, let N equal minus minus M. So what is that going to do? That is going to first that's going to subtract 1 from M, meaning that it's 8, and then assign that 8 to N. So when we get done, M should be 8 and N should be 8. On the other hand, if I do this, if I say N equals M minus minus, now it's going to take the value of M, which is 8, and assign it to N. Then it will remove 1 from M. So now N is, M is 7, sorry, and N is 8. All right, and the plus plus and the minus minus can only be used to add or subtract 1. You can't say let R equals G plus plus 7. It's just going to give you an error because it doesn't understand. It says unexpected number. Guess what? That's the unexpected number right there, the 7. Because again, you can only use that to add or subtract 1. It doesn't make any other sense to the system other than that. All right. And I think I've given you enough examples, or at least hopefully I have. There's a plus plus, there's a minus minus. I did show you just a minute ago, I'm trying to be complete here, that in this example, so if I come in here and say, let K equal 21, not jet, sorry, let K equal 21. And then I come in here and say, let's see, let's say I want to change the value of K. I want to add 7 to it. I can say K plus equals 7. And now it's 28. I can also subtract. I can say K minus equal 12, and now it's 16. I can say K times equal 4, which is 16 times 4, or 64. I can say K divided by equal, all right? And I can say, I don't know, let's put 8 in here, which will give us 8. Finally, I can say K modulo equal and let's say 3. 8 divided by 3 is 2 well, let's do it by 5. 8 divided by 5 is 1 with a remainder of 3. So they should give me 3. So there's a lot of different ways that you can do math, the bottom line. And there are some shortcuts that have been put in there by the system to try to make your life easier. This is the order of operations. So you do plus pluses and minus minuses before you do um, multiplication and division or modulo. And you do those before you do addition and subtraction. If you want to override the natural order of precedence, you use parentheses. All right. That's about all I would say about that. Okay, let's take a break. It is 9:05. Let's come back, please, at 9:15. We'll pick it up here on how to use arithmetic expressions in assignment statements. All right, it is 9:15, so I'll continue on, and I believe we've already looked at this. They're saying next that there's a plus equals, a minus equals, a times equals, and as I mentioned, there's also a divide equals, and there is a modulo equal. One thing I didn't mention on here that I believe still works. So if I come in here and I say, let name equals Jeff, let's put it all lowercase, I don't care. And then I say, oh, I already have a name. Okay, let my name equal Jeff. All right. You can say if I type in my name, it comes back as Jeff. So I can say my name plus equal space Scott, like that. Now notice if I say my name, it says Jeff Scott. So you can use the plus equal with strings as well as with numbers, is what I'm trying to get across there. All right. All right. So, okay, so I think we've already gone over that. So, and well, hey, maybe I'm that good, I guess. Now I want to show you something, and this is going to be confusing. Probably should have done a better job of going over with those of you who had me for the C# class last semester as well. but there is something that exists both in C# and in JavaScript that's called a template literal. And I want to show you an example of that right now. Okay, so let's say that I wanted to do this. Let's assume in here, I come in here and I say, let fn, that's my first name, equal Jeff, let ln equal Scott. Okay, you've seen this kind of stuff before. Now I could come in here and I could do this. I could say something like, let's see, let fn, I got fn, let full equal, and I could say like my name is, and then I could say on there, plus the first name, plus a blank space, plus my last name. I could do that. It'll work fine. And now if I say full, notice what it says. My name is Jeff Scott. There is absolutely nothing wrong with doing that. But notice what I'm doing. I've got a string, then I break out of my string to add a variable, then I break out of my variable to add another string, then I break out of that string to add another variable. That's totally legit to do that. There is absolutely nothing wrong with doing that. But let's talk about another way we could do that. All right, so that's let full. So I'm going to make a new one called full2. So I'm going to say let full2 equal, and now I'm going to do this. All right, I'm going to use what's called a back tick. And a back tick is on the top of your keyboard, right next to the number 1 you've got near the upper left-hand corner. So I'm putting in a back tick here, and I'm going to say I'll just say full name so you can see the difference. So my full name is, now I don't have to break out, but I need a $sign here, and I need to put in curly braces FN, and then a space, and then another $sign, and LN. Now, at first look, when you look at that, first of all, it might seem confusing. Second of all, when you look here, well, look, I got this and I got this, and they're both taking up the same amount of keystrokes, which is true. But doing it the way I'm doing it in the second example, I did not have to break out of a string. This is all now in one concatenated variable. So the idea is typically, if you've got variables of any kind that you want to be able to use inside of a string or whatever, you create them, and this is called a template string or a template literal. So if I hit enter and now I put in full2, notice my full name is Jeff Scott. It works just fine. All right. Now you're learning. If this makes a heck of a lot more sense to you to do it this way, then you should do it that way. But if we're in this for a while and you're like, I kind of really like this JavaScript stuff, and maybe one day I want to be a JavaScript programmer, you should learn to start programming like this. All right. And again, it's a back tick here and here. If I try doing this inside of single quotes or double quotes, it will not work. All right. And that's what they explained here. Now, their explanation might be a little better than mine. I don't know. I hate reading out of books to people. I mean, to me, it's kind of insulting. So there are some examples of it right here, a little later on. There we go. And this can be any kind of variable. It can be a number if you want to do that. You can even do stuff like this. I don't know why you do this, but you can if you want to. So let's assume I'm going to come back in here and I'm going to clear. And I'm going to say let B equal 12, let C equal 47. I'm just making this up as I go along. And I'm going to say now let D equal, and I'll use the backtick, and I'll say $B plus $C equals $B plus C. That should work. If I did it right, it should say, for D, it should say basically D is what? 12 plus 47, which is 59. But if I type in D, all right, well, it's given me that. Let's see. I thought it would. It does have 12 plus 47 equal 59. So it did do it, but it did it inside of a string. What I'm trying to get across to you is these can be numbers, and you can even do math on those numbers in there if you want to do that. Now, you might look at that and go, why would I ever want to do that? That isn't the point, believe it or not. The point is that you can do mathematical operations inside of a template literal. All right. What if I wanted to do the same kind of thing? All right. This is one case. I'll say here, let E equals, and it might make more sense here to do it like this and say B plus C equals, if I'm doing this right, I'm hoping I'm not missing anything. That would be another plus sign here. So B plus C equal, and then I'd say again plus, and I put inside of parentheses here, B plus C. All right. All right, it says unexpected string, so I goofed up something. Let E equals B. Oh, that needs a plus sign here. Plus, can't see if that did it. Undefined, but if I put in E now, it's literally, all right, it's going to be 59 is going to be the value. Again, I'm giving you kind of quirky examples here, but I'm just trying to show you that quite often in this language, there are multiple ways of doing it. All right. All right. Now they do say in here, a template literal is easier to read, but the plus and plus equals perform faster than actually doing the math inside of there. All right. Special characters in strings, these are escape sequences. All right. The one that you're going to be concerned with 99.9% of the time is the first one. That's a new line. That's like you hit the enter key. \n means new line. All right. Now, when you do that, there's a few other ones here, and let's look at these examples. Okay, we've got here, this isn't the time to talk about this. And you'll notice that before the \T, okay, we've got the apostrophe and we put a \/ before it. That turns off the special meaning. Starting something with a \ says that whatever comes after it has a specific meaning. So a \n means new line. A \ followed by an apostrophe means single quote. A \/ followed by double quotes means double quote. And two backslashes mean that's an actual \. All right. There's also Unicode characters that you can do with this. I'm not going to go over any of those, but you'll notice the copyright. We've always gone in our code, we've always put in ampersand copy. But if you're putting that in inside of JavaScript, you can use this, the \U00A9 for a copyright symbol. And you can see there's a few other ones in there as well. In fact, there's a whole list of them. All right. So as it says in Wikipedia here, this is a list of all the Unicode characters. I don't know how big that list is, but my guess is it's pretty doggone big. I don't really care. All right. And the U in there means Unicode. All right. Okay. How to use objects, methods, and properties. Again, please be cognizant of the fact that what we're doing in here is this is an introduction to things. All right. You are not expected to be able to go through chapters 1, 2, and 3 and boom, you know everything there is about JavaScript. I don't know everything there is about JavaScript, and I've been teaching it for several years. I typically go through this, and there's at least 1, 2, or more things that I learn every time I go through it. And if for no other reason, I come into something like this and I just try something that I've never tried before. I'm like, geez, I didn't know you could do that. All right. One of those aha moments or whatever you want to say. So JavaScript allows you to work with objects. Okay. Now, I don't expect you to understand what an object is. All right. It allows you to work with methods. I don't expect you to understand what methods are. It allows you to work with properties. I don't expect you to understand what properties are, unless last semester you took the C# class. So let's talk about what an object is. All right. They say that an object is a collection of methods and properties. What does that mean? Well, every one of us in this class, be it the instructor or any student, you're all an example of a person object. For your methods, those are your behaviors. So you all eat, you all sleep, you all drink, etc. Those would be human methods. In addition, you all have a height, you all have a weight, you all have an eye color. Unless you're totally bald, you have a hair color, etc. Those are properties. All right. JavaScript allows you, if you want to do work with objects. So objects are typically used in something that's referred to as object-oriented programming. All right, those of you who were in the C# class last semester, in about chapter 12 of our book, we started getting into object-oriented programming. But we were using objects before that because C# is, what is referred to as an object-oriented programming language. On the other hand, JavaScript is what's typically referred to as an object-based programming language. The difference between those is what that means is that when you are using JavaScript, you can use object-oriented programming functionality. You can have classes and objects with methods and properties, but you don't have to. So we'll have a chapter later on in the book that will talk about objects and how to create your own. But before we get there, let's talk about a few of the built-in objects, methods, and properties. All right. So the next figure, when we go to the next page, it shows some of the methods and the properties of the window object. And even though you might not realize it, we've already used them. All right. We use the alert method. Now, I believe, I could be wrong here, but I'm going to try something. I'm going to type in here the word window, and I'm going to hit enter. All right. And you might say, well, that isn't much. Well, look. These are all the different window properties and methods there are. You can see it's in alphabetic order, and there's a lot of them. Now, if we look up right near the top, you'll notice that the first one listed is alert. All right. And when you click on that, you can get even more information if you want that. But the point is this, the default object in JavaScript is the window object. That's why earlier you saw it when we went in and we did this. And I came in here and I said, alert, hello, and hit enter. And you get that. That is the same thing as saying window window dot alert. Hello again. And that works because alert is part of the window object. It is the default object in JavaScript. So when you're using something that begins with window, you don't have to preface it with window dot. All right. But, and I think you saw this yesterday, if I want to write something on the screen here, all right, I can't just say write hello. I get an error because it says write isn't defined. It doesn't know what it is. But if I say document dot write hello, now it writes it on my document screen right there. All right. So document is an example of a built-in JavaScript object as window is. In fact, if I do a console.clear again here, all right, and I type in document and hit enter, all right, it's what's in my document right now, which isn't very much. It actually created a new document for me. All right. Finally, the last thing, notice when I do this, when I type in console.clear, I'm using the console object. All right. So if I type in console and hit enter, it says these are different things that you can do with a console object. You'll notice there's a lot less of them than we had with the window, but one of them is clear. All right. And there's other things that we can do in here as well. All right. So if you want a little bit more on that, again, we'll have a whole chapter later that'll talk about object orientation in JavaScript, but it'll be quite a while from now. All right. And they show that prompt. We did that yesterday, if you remember. We did the prompt, so there's nothing really new there. All right. We also yesterday talked about parse int, and we talked about parse float. So you saw examples of those. All right. Here's a prompt, but we're actually, right there, we're not parsing it into an integer or a float. Typically, that's what you do. Now, JavaScript is a little funky. And what I want you to understand is this. All right. Let's see, let's go back. No, we don't have that up in there. I don't know if I can do this with a console or not, but I'm going to try it. All right. So let me clear the screen. And you saw this yesterday when we did something like this. So if I say I don't know, let your name equal, no, let's do it this way. Let your salary equal, and I'm going to put it in like this. There's a reason I'm doing it the way I'm doing it here. I'm going to say parse int prompt, what is your salary? Like that. Okay. And I'll give it a default of say $100,000. All right, just like that. And I hit enter and it says, what is your salary? So I'm going to come in here and I'm going to put in 555 and hit enter. Now I'm going to type in here, your salary. You can already see it's coming up with 555. Nothing fantastic there. All right, but I'm going to grab this again. I'm going to grab this. I think I can copy it. I'm going to try at least. So I'm going to copy it and I'm going to do it down here and then paste it in. All right. So it's going to ask me again, your salary. And I said, when you do that, you can't put anything illegal in there. You saw what happened when we put in hello, it comes up with NAN, etc. But what if I do this? What if I put in 1,000, then I put in the word hello? All right. Well, you can already see what happened. Your salary is now equal to 1,000. Why did that work? Because when you do this prompt statement here, let me bring it back one more time. All right. When you do this, it reads, as long as there's a number, it keeps reading. And as soon as it finds something non-numeric, be it a blank space, be it a letter, be it a special character like a comma or whatever, then it stops. All right. And the reason I'm telling you this is I'm going to do one more thing. All right. So what is your salary? I'm going to put in here 123.456. Now, technically, that should be illegal because I'm saying parse int. But I think what it's going to do is it's going to set the salary to 123. As soon as it sees that period, that's an illegal character in a parse int. So it's going to stop. I don't think I'll get an error. All right. And again, your salary, 123. All right. So this is one of those times again, where, as I mentioned before, JavaScript in many ways is a very forgiving language. It allows you to do things that other languages, most other languages, won't allow you to do. You saw the NaN yesterday, the not a number, so that isn't anything new. All right. I've also shown you the write method to write stuff on a page, and I've shown you the to fixed. All right. So we've already looked at these, is what I'm telling you. All right. Now, the chapter ends, we've got about 10 pages left, as it says here, with 2 illustrative applications. So the chapter ends by giving you 2 apps that illustrate the skills you've learned. The first is the miles per gallon. It'll be very similar to the one that I did for you yesterday from scratch. But what I'm concerned with is this, all right? That you understand what's in here. Now, they're showing this embedded right inside of JavaScript, which stinks. You shouldn't do that. So I'm going to change their program. All right, I'm going to bring up their example and I'm going to make changes to it so it looks more reminiscent of the way it should look, in my humble opinion. All right, so we'll bring that one up and we'll do that first. Then we'll come back and look at this test scores application. So let me come in. This is now chapter 2. All right, so first I'm going to bring up MPG and I'm going to bring it right up inside of code. All right, this is the same one that's in the book. So here's some CSS. Here's the index.html. And you can see our script is right in there. So let's make this look the way it should look. I'm going to start by clicking down here, adding a new folder and calling it CSS. And inside of CSS, I'm just going to literally move this file. So I'm going to click on it, hold down, and drag it up here into the CSS folder. It says, do you want to move it there? Yes, I do. All right. Then next, I'm going to come down here and again, I'm going to create another new folder and I'm going to call this JS. And inside of JS, I'm going to come in and create a new file that's going to be called script.js. You can call it whatever you'd like. And notice I can tell if this worked because if I click down here and close my CSS folder, I no longer see the mpg.css. And if I close this one, I no longer see script. In fact, let's rename this. Since we call this mpg.css, let's name this one mpg.js. Okay. All right. So now we've got this, and we've got this mpg.css. That's in there. We've got this, and it's empty. So let's fix the program. First thing is for our link, we now have to say CSS/. All right, so that should work. All right. And secondly, I want to grab everything that's in between these script tags, everything, cut it, and I want to put it inside of mpg.js. So I've got my use strict statement, and I've got the rest. We're going to go over all of it in just a moment, but I want to come back to here, and inside of main, Okay, I don't want this to show anymore. I can keep that H1 tag. And let's say right below it here, again, we could put it up here with a defer, but I'll just put it down here. And I'm going to say script source equal JS slash MPG, whoops, slash MPG dot JS script. And this should still work, hopefully at least, we'll see right now, the way it did before. So file save all, and let's go in and run this. All right, enter miles driven, 348. Enter gallons used, 19. Hit enter, whoops, way too big. Put it at 100%. There it is, I'll blow it up a little so you can see it. So that's at 250%. All right, 348, which we had said for our miles, 19 for our gallons, and MPG is 18.32. So it still appears to be working. Let's go back and dissect or take a look at. There's nothing to really look at now in the HTML. You know, we've got our link to our CSS. We've got our link to our JS. I think we've reached the point now where we don't have to look at our CSS anymore either. All right. Now there might be stuff in here you don't remember or whatever. There's our font family. Our background color is white. We've got a blue border. Margin 0 auto means center it on the screen. It should be 600 pixels wide. We should have padding, and I believe that's top and bottom is 0, and left, I'm sorry, top and bottom is 0. Right should be 2 M's. Left should be 1 M. Our H1 should be in blue. Our label should display on the same line as the output. That's the inline block. And the label should have a width of 5M. Okay, fine. So let's close that. We don't need that anymore. So let's look at this. All right. Now, you'll notice here that where I used let yesterday, they're using const everywhere. Now, is that okay? The answer is very political, yes and no. Yes, it's okay, as long as we're sure you're putting a number in here, because you can't change it. Whatever you put in there is going to be your miles driven. Whatever you put in there is going to be your gallons used. If, like we did yesterday, we wanted to come in and we wanted to put this into a while loop, all right? If we wanted to do that, where if you made a mistake, we would ask you to do it again, we couldn't use const. So let's change that. Let's change this to let. All right. And I'm going to come in here then, and I'm going to say while is NaN miles or miles is less than or equal to 0. All right. And if that's the case, I just want to put this in again. I don't say let, I only declare a variable once, but I can come in here and grab all this and I'll put that in there. And now I'm going to do the same thing for gallons. I'm going to have this say let. I'm going to grab this. Let me close that so we've got a little more room to work with. And again, I'm going to put in here while is NaN gallons or gallons less than or equal to 0. Whoops, try that again. And we'll paste that in. Now this one can stay a const. That's totally fine. We've already got our ending number for miles. We've already got our ending number for gallons. All right. This can be the same. And now notice what they're doing here. When you use backticks, these template literals, you can put stuff over multiple lines. This is all that output that you saw on the screen. And not only that, I should be able to come in here and say miles dot to fixed. I think it'll take this. We'll find out. To 2 decimal places. Gallons. Yeah, you did it here. Gallons dot to fixed. to 2 decimal places as well. So what are we doing here? We're coming in and we're telling it to use strict mode. All right, so what we're saying is if we don't initialize variables before we use them, all right, like this, if we don't initialize them, flag it in the program. We're telling it strict mode. We're telling it to look at this and make sure we're writing the program the right way. So it'll say enter miles driven. If we run this and we put in something non-numeric or we put in something negative, it should ask us to do it again. And it should keep asking us to do it until we put in a positive number. Once we put in a positive number, it should do the same thing, but with gallons. Once we put in a positive number for both, then it should do the calculation and display the results. All right, and it's displaying them on the screen. All right. Now, since we're displaying them on the screen, the paragraph tags, etc., work. But my guess is if I do come in here and I say alert HTML, it may look kind of funky. I don't know. All right. So I'm going to do a file, save all. I've got to go back to my index.html page and let's run this. Very similar to what we saw yesterday, but we're not giving it a default value. All right, if I leave it blank, it asks me again. If I put in something non-numeric, it asks me again. If I put in something negative, it asks me again. If I put in 0, it asks me again. If I put in 128, now it asks me about gallons. So again, if I leave it empty, it asks me again. If I put in non-numeric, it asks me again. If I put in 0, it asks me again, and a negative number, it asks me again. If I put in 3.8, that's valid. So now look at this. That's what I get first. So that's not the way I'd want to display it inside of an alert, because it's taking everything literally. It doesn't know that this P tag here, it doesn't know that that's a paragraph, but it'll still look fine right there. All right. Now, unless you've got any questions, Grant, I'm just going to go on and do the next one. Hopefully that just all made sense.
I don't have any questions right now. Thank you.
All right. And again, for those of you watching this on tape, if something doesn't make sense, it is your responsibility to ask me. I'm more than happy to work with you on it. All right. No problem at all doing that. So I'm going to grab this one line that we put in here with the alert and just comment it out with // All right. So I'm going to do a file, save all. All right. And I'm going to do a file and I'm going to close this folder. All right. That's everything in that particular example. So let's go on. Oops. Okay. Let's fine. Close that. Oh, I guess it's still open. Okay. There we go. Okay. So now there's a second application in here, and it's a little bit different. Okay. So it says figure 217 presents a simple app with a prompt that lets the user read in 3 test scores. And after the third or all 3 have been entered, it calculates the average by adding the 3 up and dividing by 3. It says here, unlike the previous one, this one uses an external JavaScript file, which is the way they should be showing everything from now on. All right. Now notice it starts by declaring a variable named total, and it initializes it to 0. A variable is used instead of a constant because it's changing. Next, it has 3 prompt statements for each one of the tests. All right. Then it divides it by 3. Right? And it passes that to the parse int, so it's throwing away any decimal place. All right. Finally, it says constants are used to hold the entries and the test average. Notice the JavaScript code. It says it's has a use strict in it. So if we look at this, this is what it looks like. It'll say enter test score. We'll pretty ours up a little. So it says enter test score 1, then enter test score 2, then enter test score 3. We'll also set up a couple constants, and we'll say the minimum test score you can get is a 0, and the maximum test score you can get is 100. And we'll do that to not only verify that they put in a test score that is numeric, but also that they put in a test score that is within range. So we'll do both of those. All right. So this is their program. This is what they have in their scores.js file. And I'm going to pretty it up a little bit. All right. And show you what we have. We'll take a look at that. And then we're almost finished with the chapter here. All right. So let me bring that one up. All right. And again, I'll save both of these when I get done, just in case anybody wants to see them, and I'll put them out there on in a GitHub repo. So let's see, open with code. So again, let's do this the right way. Come into here. Let's bring in a new folder called CSS, and let's drag our test scores into that folder. Yes, we want it there. And let's make another folder here called JS, and let's drag our test scores.js into that folder. All right, double check, close the CSS. Yep, I didn't move this one in the right place, so let's move that again. All right, now in my CSS folder, there is test scores.css. In my JS folder, there is test scores.js. All right, and in our index, again, we're going to have to come back in here now. And for our style sheet, we'll have to change this to CSS/test scores.css. And in our main here, this will now be JS/test scores.js. Those should be the only changes we have to make in this file. So I'm going to do a file, save all. I am going to bring up my CSS file to quickly look at that. And I'm going to close this HTML file. All right. Body, pretty much the same thing we just did. All right. H1 is the same. Label, we're floating it to the left and giving it a width, aligning the text to the right. Any input, so this is input of type text in this case, or of type number, I think would work too. We're giving it some left margin and some bottom margin, and we'll put a span in there that's going to be red by default. Okay, so we'll close that. And let's open up our test scores.js. And again, what I'm doing in here, I'm not at all making any comment on the author. But what I'm saying is, let's write this in a way that hopefully at least makes a little more sense. All right. So I'm going to come in, and before I initialize the total variable, I'm going to declare a couple program min, max constants. All right. Now these I am going to put in uppercase. You don't have to do that, but I'm going to say const min test score equals 0, const max test score equals 100. You don't have to make them uppercase. All right. But I'm now going to be able to do range checks on every variable. Now, Grant, I know you know this already, but in here, that's doing the same thing 3 times. All right. And you might say, isn't there a way to just do that once? And the answer is yes. In fact, when we get to the next chapter tomorrow, we'll look more at loops and you'll see a better way of doing that. All right. But for now, we're not going to worry about it. All right. Now, notice that total is a let. Why? Because we're changing its value here and here and here. That's why it's a let, because its value is changing. All right. So let's change this one as well. This I'm going to make a let because we're going to do some checks on it in just a minute. This I'm going to make a let, and this I'm going to make a let. The average can stay the way that it is. That's fine. All right. So I'm telling it over here to prompt for a test score, but I'm going to even change this. All right. I'm going to say for prompt for test score, I'm going to come in here and use my backticks. Okay. And I'm going to say between, and I'm going to put in here min test score and max test score. I think it'll take this. We'll find out in a second. All right. So now it'll say enter a test score between 0 and 100. All right. Now, just so you know this, all right, and put in my other backtick. All right. I could have just put the number in there, 0 and the number 100. But what if we have some tests that are only worth 50 points? So I might come up and change this from 100 to 50, but I may not remember to do it down here. Now it's always going to be using these two values. All right. Okay. In fact, let's do this. I'm going to grab all of this and put it on another line just so you can see everything. All right. So now I'm going to come in here and I'm going to do my check. And I'm going to say while is NAN test, oops, that's score 1, or score 1 is less than min test score, or score 1 is greater than max test score. And again, let me put this on multiple lines so you can see everything that's going on here. All right. So if any of those are the case, I want you to do it again. So if that's the case, I'm going to tell you to do it again. Now, eventually, because you're in a loop now, eventually, you're going to have a valid test score. So you will add it here. Now, to make this go faster, I'm going to just grab everything here and I'm going to copy it down to here. And every instance now in here that I've got score 1, I'm going to make this score 2. So that'll be a 2, as will that, and that, and that, and that, and that. All right. And whoops, and I made that 21, which is going to goof up stuff. And let's do it one more time right here, but we'll make it score 3. All right. So this will be score 3. All right. And this will be a 3. So will this, and this, and this, and this. So now what we've done is we've done a few things. The first thing we did was we came in here and we established boundaries. Those are our constants for our minimum possible and our maximum possible. Then when we came in, rather than just supposing the person was smart enough to put in a value that worked, we're asking them to put in a value between 0 and 100. And if they put in something non-numeric, or they put in something less than 0, or they put in something greater than 100, we ask them to do it again. All right. And the only other thing I would add to this, where we've got enter test score here. All right. We could put in here, let's see. Well, this is kind of a crummy way to do it, but I'm going to put in the number 1 there. Enter test score 1. All right. And I'll put it here also. There's better ways of doing it, but we haven't gotten to that point yet. So this will say enter test score 2. You hear anything behind me? It is the first Tuesday of the month. So they are doing testing right now of their emergency systems. So if you hear anything, that's what it is. All right. And then we're adding test score 3, test score 2, and test score 1. All right, when I save, it might go and put those blank lines in again. It looks like it didn't. Now, one thing I want to mention in here. All right, what if we didn't do this? Okay, in other words, what if we came down here? Here we're adding the value of total. We're adding the value of total. We're adding score 1 to total. Then whatever total holds, we're now adding score 2 to it. And whatever total holds, we're now adding score 3 to it. So in other words, what that's doing is it's saying total equals score 1 plus score 2 plus score 3. There's a reason I'm showing you this. What if I took this and divided it by 3? It's not going to work. Let's assume, I'm just making this up. Let's assume that score 1 was a 50 or a 40, that's fine. Score 2 was a 60 and score 3 was an 80. 40 plus 60 plus 80 is 180. If you divide that by 3, it would give you 60. That's not the answer you're going to get here. Rather, it's going to take 80 and divide it by 3, which is going to give you like 26.6. And then it's going to add to it 60 and add 40 to it. So in that case, it's going to say your total is 126 to 40 something. The bottom line is this. If you decide you want to do multiple mathematical operations like this, you have to make sure that when you want to do the addition first, that you put it inside of parens like that. All right. All right. Sorry, that was just a little. We left for a second and we're back. So let's put this in. Could I have screwed it up? Hey, it's me. I sure as heck could have. So I'm going to do a save all here. I'm going to go back because I can remember I can only run my HTML file under live server. So let's try that. All right. Now it didn't like my min test score and my max test score. So it didn't like that. I thought it would take it and it didn't. That's okay. So let's come in here. Let's put in something out of range. -4. And it tells me to do it again. 101. And it tells me to do it again. Okay, that's good. Let's use the numbers we just used. 40, 60, and 80. All right, so it should add 40 plus 60 plus 80, which is 180, and it should divide it by 3 and give us 60. And it did. So that works just fine. Let's fix what is screwed up in here. So like I said, there's probably a way to do it. It may be that you can't use backticks in a prompt. That's probably what it is. So let's fix it so it does read it the way we want it to. All right, so enter test scores between, and I'm going to put this over multiple lines so you can see it. And I'm going to put here exactly what we have without the curly braces. So min score plus and max score like that. That should work. Let's see between, I need another plus sign there. There. All right, so let me grab this. We're putting that in here and we'll change this one. All right, and we'll have to change this one. And I'll have to change that to a number 1. And we'll change, oh, that should be a 1 as well. And then that's a 2. And that's a 2, so that's correct. And finally, we'll do it here. And that'll be a 3. And so will this. All right. It looks a little funky. Again, you'll have the code. All right, when we get done. So let me do a file, save all, and let me run it again. Now notice it says enter test score 1 between 0 and 100. Never try to insult a person with any message you put in here yet. Never assume they know what the heck they're doing either. So make it as nice for them as possible. So again, non-numeric doesn't take it. All right. Out of range doesn't take it. Out of range the other way doesn't take it. 87. All right, I already tested it. It's the same test, but 69 and a 93. All right. Now, if I wanted this and I wanted the decimal place that was in here, I could do that. All right. And if you notice in here, for the average, we've got parse int total divided by 3. I could change this to a parse, come on, Jeff, get that out of there, to a parse float, which should save it. And then I could say average here, dot to fixed, and do it to 2 decimal places. All right, let's save it and try that, and that'll be pretty much it. So let's say 56, 79, and 100. All right, so now notice that the average is a 78.33. All right, okay, let's finish this up then. I want to get rid of this, in this, in this, and we'll go back to the program. All right, so that is it. All right. So it says, if you have programming experience, you can see how JavaScript is similar to languages such as C#. If you're new, this was meant to just be a beginning. I would strongly suggest that if I'm losing you already, if something doesn't make sense, you would look at the end of the chapter because they have some exercises in there. Not only do they have exercises in there, you have the answers to these exercises. And under book apps or whatever it is, you have all those are exercises. All right. Now, tomorrow, we're going to continue on and we're going to go into chapter 3. And we're going to talk about what are referred to as control statements. And we will again look at some more examples. That's really all I had for today. Any questions on that program, Grant?
Not really, because it's like the book just said, it's really similar to a lot of the stuff.
Yeah, it is.
Semester.
So for those of you who had the C# class last semester, you probably think, well, this is real similar to junk we did before. Tomorrow will be the same way. We'll eventually get to the point where we're going to be doing something where we want to bring in, we really haven't exactly been bringing the HTML back into here, but we will. All right. And we'll be doing other stuff. So, all right. So if there are no questions, we'll pick it up tomorrow after we go through this. Then what I'm going to do is I'm very quickly going to show you the homework and the labs that you're going to have to do for chapters 1 to 3. And then I will pick out certain ones from there. We'll do most of them as a class on Thursday, just for those of you who have little to no experience, so you can see what the heck you're supposed to be doing. All right. So with that, I will, Grant, thanks for and I will see you all tomorrow. Have a good day.
Thank you, you too.